Welcome to the first of 3 tutorial videos for Lesson 3.2, Proving and Applying the Sine Law. By the end of this lesson, you will be able to explain the steps used to prove the sine law and use the sine law to solve triangles. In part 1 of the videos, we're going to prove the sine law. There are different ways to prove the sine law, but in one way, what we do is we draw an acute triangle and label it ABC. So here we go with an acute triangle, ABC. And what we do is we add a vertical height to it, a line, and we say that it meets line BC at point D. And we drew it in such a way that it makes a 90-degree angle with that base of the acute triangle. Because we drew it that way, we have 2 right-angled triangles that we can use to help us prove the sine law for the bigger acute triangle. So we're going to do this in 2 parts. First, let's look at triangle ABD. So the triangle on the left. In this triangle, let's set up the sine ratio for angle B. So we have the sine of angle B is equal to the opposite side, which is side AD, that one we added, and over the hypotenuse, which is side C, because it's opposite of angle C in the big main triangle. So we'll have little c on the bottom. Then what we're going to do is rearrange it to get AD by itself. So we multiply both sides by side length C, whatever that happens to be. We multiply because it is the opposite of dividing, so it will cancel out the dividing by C on the right side. Then we rewrite what we have. So we have side length C times the sine of angle B is equal to side length AD. Similarly, we're going to do this for triangle ACD on the left-hand side. We are going to set up the sine ratio for angle C at the bottom right-hand corner. So we have sine of angle C is equal to the side length opposite, which was AD, the one we added, in the right triangle, and then over side length B, the hypotenuse of that blue right angle triangle, is side length B because it's opposite of angle B. Then, just like we did before, we're going to rearrange this equation to get AD by itself by multiplying both sides by side length B. These multiplying and dividing by the same number just equals 1, so they cancel out on the right-hand side. We are left with B, side length B, times the sine of angle C is equal to AD. Now, in chapter 2, we looked at the transitive property. So we're going to use the transitive property now. Because both sine C times sine B and B times sine of C are both equal to the same thing, side length AD, then they must also be equal. So we can say, therefore, C times the sine of angle B is equal to B times the sine of angle C. And again, that's the transitive property, which we covered in chapter 2. Now, to get this looking like the sine ratio, we're going to take our what we just wrote, our conclusion by the transitive property, and just rearrange it to get the similar letters on the same side. So I'm going to divide both sides by sine of angle B to move it to the right-hand side. So I'll be left with C times B times the sine of angle C over the sine of angle B. And then, just like I did to move the sine B over, I'm going to move the sine C over to the other side and divide. To do that, I have to divide both sides by sine of angle C. Now to rewrite that, that leaves me with bottom, we have C over the sine of angle C is equal to B over the sine of angle B. So that's part of the sine ratio. We have to prove that the angle A and side length A can also be equal to these two ratios, and we're going to do that by kind of repeating this process with angle A's and angle C's. So I've redrawn my acute triangle ABC, but now I'm going to draw the vertical height. If I was to rotate this so that B was at the top, I could draw a vertical height straight to side length AC at a 90-degree angle, and then use that as my two right angle triangles. So the red one and the blue one are both right angle triangles. Now what we have is we're going to redo that process that we just did with the other triangle with these ones. So in triangle ABE, we're going to make that meet side length AC at point E this time. We are going to have the sine of angle A equal to opposite, which is side length BE, over the hypotenuse of that right angle triangle, which is side length C. So I can rearrange that to get C by itself, multiply both sides, to get the C over to the left side. So I have C times the sine of angle A is equal to BE. In the blue triangle, triangle CBE, I can say that the sine of angle C is equal to opposite, which is BE, over side length A, opposite of angle A in the big acute triangle. Get BE by itself, multiply both sides by side length A, and you get side length A times the sine of angle C is equal to BE. Because both of those statements are both equal to BE, I can conclude, therefore, that C times the sine of A is equal to A times the sine of C, angle C. Similar to how I rearranged this before, I can rearrange this so I have C over sine of angle C equals A over sine of angle A. Now we have both the ratio for the side length and sine of A and the ratio for B and the sine of B, angle B, are both equal to the ratios with the C's. So because they're all both equal to C's and the C's are equal to the other two, I can say that all three are equal now, and there is my sine law. You can also see this explanation in your textbook on pages 132 and 133.